All right, can you see my screen? Anybody that's looking, can y'all see my screen that looks like this? Okay, thank you. All right, so I'm gonna go to, I'm recording, go back in. The problems that I'm gonna work are gonna come out of assignment 2. Right here. So I've got it as a class assignment, as unit of measurement and conversions. Today is the 19th. You do not have to have your book, but I want you to write them down, and I'll check off on that. Look at everybody's paperwork before they leave today and give them an activity grade for today. So you don't have to have your book, because I'll write them down. And I'll be writing them on the whiteboard that's inside this chart. So when they asked us if we wanted these sharp aqueous boards for the classroom, I was like, I got to see how it was demonstrated and how it worked, and I was like, yeah, definitely won't want it. And it's been a lifesaver with all the stuff that's went on during COVID. But it's the bad thing about this, if you're back there, that's why I tell y'all to log into Blackboard so that you can see as I'm writing. You'll be able to see on the board as I'm writing. But to me, it's just I love it. That's all I can say. I love it. You can roll it around. It can be used in a different room. I like it because of that. Smart boards, they had them set up here, and a lot of times they couldn't see the screen, and unless you were close up, sometimes it was getting in the way. So when they talked about getting one of these, I was like, yeah, I'm all for it, especially if I'm trying to demonstrate something and I don't have to put you in the dark like the overhead would put you in the dark. All right, so I've already printed me off the problems, so I'm going to start writing them in, and then I'll tell you, I've already got my textbook up. Right here, I'll tell you the ones that we're going to put in and what pages they're on. Okay. So where I'm going to get some, and I'll tell you exactly where I'm getting the conversion from. I'll either be getting the conversion to do our conversions in the front cover of the book, which is going to be here. So here's the conversions. That's in the front corner of the book. So I'll say I'm getting in the front, and I'll explain to you what they are, or they come out of the chapter, which will be I'll let you know exactly where I get the formula from. Here's why I'm doing this, because when you first have your first test in this, you will have worked every single problem that you could expect to see. We'll have done every type of conversion you would possibly ever see on the test. So I'll know you have some good, clean copies and have worked it. So, because what happens is I let you use your notebooks. So I want you to have something in your own writing where you can kind of understand it. So here was where I left out yesterday. So some of those conversions come out of the chapter right here. All right, so let's get started. So we're going to work T4. That writes on it. One year I lost one pen. I lost this pen, and then I lost the second pen. So I didn't have either pen. Come to find out, they both had fallen in between here. There was like a little part on here of the desk, I didn't know where it was. I'm looking for my other one right now, see where it got to, because I hadn't seen it since last night. I can use that one, I just don't like it as well. Yes, it fell in here. Let's see. Is that it? Giovanni, you were in here last night. Mr. Manish right on the board at all?
Yep.
Okay, thank you.
Is that it behind you?
Yes, it is. Thank you. That's what I was looking for. I normally leave it up here with the eraser, that's what I said. Anybody seen it? All right. Y'all can see my whiteboard, right? So I'm gonna do 2-4. So it's wanting us to convert. So they were given this, it's wanting us to convert it to US survey feet. So this is 2.4. There's an A, a B, and a C. And A is and I'll have anybody that's got a book for you to kind of compare to make sure I wrote it wrong before I get started. Because I'm bad for turning numbers around. Right. So I got an A, B, and C. So A was given, and it said it was 4,129.574 meters, and it wants us to convert that to US survey feet. The second one, all three are in meters. The second one is 588.234 meters. And the last one was 102,302.103 meters. All right, so they're wanting us to convert it. I'm gonna go ahead, US survey feet and international feet. So US survey feet, there's a couple of different ones. I'll show you at the front. It could either be one meter equals 39.37 inches. Or, and that's from the front cover, or the other one was actually in the text of the book. Wasn't in there, they talked about the two. They said, and the US survey feet is the one that was adopted. Let me change one thing to see real quick. So we're going to be looking at the one that was adopted in 1895 because that's the US feet, where it was equal to, I'm going to write this down, 39.37 inches were exactly 1 meter. And then there was a new standard. So this right here is the answer. Either way. Slide it a little bit. I think it's called SFT. Okay. I can use either one to solve the problem. Either one. So it's given me, they want the answer in US survey fee. So a lot of times you'll see them write SFT for survey, US survey fee. There's not but a tiny, like the other one is, for if you were going to use the international foot, is 1 foot is exactly 0.3048. So they stop right here. But since we're doing the US survey feed, we've got to keep it all out. So let me go ahead and start with the first one.
For the meters to inches conversion for a survey foot, that is defining that inch as precisely 1/12 of a survey foot, right?
Yeah.
So that's
12.
effectively a survey inch, quote unquote. I don't want to call it that, but that is a different inch than a international standard inch.
There's 12 inches in a foot. So I could do it. I would have to, if I wanted to put that in foot into a feet to be able to work it, I would have to divide it by 12.
Yeah.
I'll do them both ways just to give you an idea, and y'all can just say which one you feel more comfortable with. All right, so I'm gonna do, all right, so it give us this. All right, what I'm gonna do is I'm gonna look, what is it wanting me to solve for? SFT. So based on this, if one SFT equals 0.304806, when I put it in here to solve for it, if I'm solving for SFT, that goes on top. So whatever you're solving for will go on top, and the other number will go on the bottom. So like I said, we'll work every example we could probably come across to get plenty of practice. So what's going to happen is the meters will cancel and you'll be left with SFT. So I'm going to take 4129.574 and divide it by that 0.3048006. This is one of the ones that supposedly has the answers in the back of the book. So I got I'm just going to kind of keep it all the way out. And they've had, for my solutions, it came out to 13,548.44. Now, right now, I'm not asking for significant figures or anything like that. I'm just having us just work the calculations. So I normally write what the conversion is. That way I'll know which number to put on top is what I'm solving for. So for the next one down, I'm gonna do the exact same thing for the rest of these. Physics, chemistry, they love all this. And that's what they're doing is mostly conversions. And I see you're shaking your head, so you must have it in high school.
Yes.
Okay. So yeah, they're big time into conversions. There's only certain ones I do in surveying, meters to feet, inches to feet, square feet to acres. That's about the gist that I do. Feet to miles, and all those numbers I know off the top of my head. If I wanted to know how many, if there's 8 inches, and I want to know, put it in decimals of the foot, I know all that off the top of my head. It would be 0.66666. If it's 10 inches, it'd be 0.83. 2 inches, 0.16. Be 0.02. I do them all the time. I take house plans that are given to me in feet and decimals of the foot, and I convert it to engineering. So I'll put it in decimals. I do it in decimals of a foot instead of inches. And then we have to convert square feet to acres. So there's 43,560 square feet in their acre. 5,280 miles, feet in a mile. So those are ones I do every day. This stuff, we don't see that often. I do get some odd ones where they have the measurement in chains and lengths. White, do you have a question?
Yeah, where in the book does it say, or I see on here it says, 1 meter equals 39.37 inches.
Okay, so that came in the front of, that was in the front of the book. This one, actually, I'm gonna show you where it is in the book. It actually comes in the writing in the book.
So you can just multiply, 39.37 times the meter.
No, because then it's gonna put it in inches, and then you have to convert it to feet, but you could do that. And I'll work on both ways, just let you see, and y'all can decide which one's better. Here was where I got this from, was right in the text. It says, under the standard, the foot is approximately 0.3048006. That's on page, I got a page number in the book. That's 23 of the textbook. Right, yeah, 23. And then it also says if you're, and that's what they call SFT, but if I was working in international foot, then you would use the 0.3048. There's not much difference. I'm talking about very minute between the two. But typically, I noticed that under board rules, we have to put our measurement in the U.S. survey feet because of all the old deeds and things that were recorded prior to this new one that was done in the 50s. The international foot, that was 1959. And I see all kinds of documents prior to that. So that's why we have to use the 1893, 23, right here, 23. So it's in the first paragraph on 23. All right, so does anybody want to give me the answer to B?
I got 1,929.879, or 897.
897?
Yeah.
I would agree, because they went ahead and just rounded it up to 2.
So why are we not doing significant figures?
We're not doing, I'm only gonna do it for certain answers. When they specifically say significant figures, then I'll go into those.
Surveying will generally include the conversion factor in a limiting number of significant figures, correct? So like if I'm using the 39.37 inches per meter, that would limit my significant figure to 4 no matter what, correct? Okay. Some applications or conversion factors for significant figures, which is less than precise one.
They do, and they only ask you for a number of things. And when I start getting into soils and foundations, when I set up some quizzes, if they don't keep it in the right significant figures, I can't think of every single thing they're gonna put in. So I tell them, make sure you keep it to so many decimal places, and at the end, don't round and put it in significant figures.
So I divided, what I had 4 by 12,
Mhm.
get it into feet, and I was off on the decimal point. I had, 13,548.35.
So you do. I'll flip over, I'll do them. I'll flip one page over and we'll do them, because that would be, you would have to convert it to inches first. So it'd be something, I'm just gonna put it right up top. So the 1 meter is, I write it down? Okay, let's see what I get if I do that. It's just multiplying it. All right, that's what I got too. So once I got that first answer, that gave me inches. So I'm working the first one. The reason I was saying, when I was out in the field, I would do that conversion a lot, because I could remember 39.37 better than I could remember this long number. I would do that, but if you do that, it's gonna throw it off. I can follow what you do, but if you use that, that's in inches. And if you wanna convert it to feet, there is 12 inches per 1 SFT. So if I got here,
Never mind. I got it now.
well, I got exactly what you had though. I was off just a tiny bit.
I got 4,449. I don't know what I was doing.
I got 0.4309, if I did it right. So that would put me doing 3 different conversions and not just one. So that's why I said I like this one. But if you worked it on a test, I'd be able to follow which one you wanted to use. Last one. And we will work plenty of these, so you'll be familiar with them. Anybody want to tell me what they got on the third one?
335,606.160.
You got 636. Point what?
656.
654?
656.16.
Okay, I got you 16. So they have 15 in my text books. I'm gonna put it in real quick. Check it. Sometimes I wouldn't say that my solutions manual is right all the time, because they're not. I put something in wrong. So I agree. I'd say 1602. That wasn't too bad now, was it? So you're writing it down right now so that you can show it to me, right? So at the end of the day, I'm walking around and say, good, activity ready.
How do you know, where to round up or?
I would say keep it in your calculator and you round at the end.
Okay.
So using the calculator, I just put it all in and then round at the end.
So for the first one, you said 4129.574 times 0.304, 800.
No, right here,
On the first one,
that one?
yeah. You just times that by the bottom number?
No, I divided it by, so because I multiplied it by 1 and it's 1 divided by that number. That's in parentheses. So that if it's on the bottom, it's going to be divide. And if the number's on the top like it was here, we would multiply.
So you're putting all that in the calculator at one time?
You can. I can do 4129.574. I can put parentheses, 1 divided by 0.3. Because you multiply anything by 1, it's itself. And it'll come out. And then I put the parentheses after the end. The one where you divided it. Zero, there's extra zero in there.
Full stuff.
They don't take it a second slip. Everybody, not too bad.
Where's
So-
the data conversions were again?
Where they are? They're in the front of the text. So in this one, I'll be getting some from page 23 in the textbook and 24. So some of them are going to come from here, where the 1 foot equals 12 inches. These are going to come from chapter 2. And then some are in the very front of the book, but since I have an online PDF of this, it put it right before chapter 1. It put that conversion table. So this is an online textbook. And they put it right below this. Right there. So that's actually in my, and I have mine is a hard copy. It's in the front. If you get an electronic version of it, it's probably going to be, in the first, looks like I'm on page 23. So I'll make sure to write it down. So usually my tests are open note, open book, because in engineering or surveying, we always have reference material. We're always going to have reference material. It doesn't matter what exam that we take, licensure, we have reference material. So I've decided, years ago that, and one of the engineers that taught out here was telling me, they're always going to have reference material. So we want them to have something to look at, because in real life, that's the way it is. That's why I've always let them use their notebooks on exams for reference material. I have one other time just gave them these, the front page and that one page, and then told them to work it. But typically now I just say, it's open note, it's book. Here's the test, and let you work them out. Because in real life scenarios, if we take any exam like that, surveying exam, engineering exam, or we're working a problem in real life, we have reference material. Don't mean we know how to do it, but at least we have something to look at. All right, so next one. So I'm just going to do one page over. And we are going to be doing 2-7. So 2-7 is giving me an area. And the reason I know it's an area is because it's in square feet. So it's giving me an area in square feet, and it's wanting me to convert it to acres hectaacres, and square Gunther chain. Alright, so this is one I do a lot. When I'm doing surveying, I can get CAD to give me an area, and the area is gonna be square feet. So I can do an inquiry and get it to give me area, but then I need to put it in, acres, so whatever the square feet is, I'll just divide it by 43,560, and I put both those quantities on my maps. So that's something, every day, we have to, when we record maps, we have to have square feet and acres of the parcel. So typically I will, I knew CAD can give me the area, and then I'll just convert it to square feet. So or acres, I need the first one in acres. So I'm gonna write out, and it came in the textbook. That's one in chapter 2. Just so you know, page 20. It's on page 24, and it's in the writing below where it says, the most common use of large areas is 10 Gunther chain equals 1 acre. So I'm gonna write that here. I don't know if they put G, let me see how they do their conversion. It's also in the front too. They choose. Ten Gunther chain is equal to 1 acre, and $43,560 feet square. I'm gonna write acre out. I'll normally put AC for acre. So the first one, they want acre. The second, they ask for I'll show you in the book in just a second. First one, acre, hectaacre, and square Gunther chain. Mm-hmm.
That is a comma between 3 and 5, correct?
Ye-
C squared?
Yeah, I'm not.
No, 43.
Over here?
Yes, ma'am.
Yeah, it's a 43,000, I'll straighten it up.
Thank you.
Yeah, you have to, I've been practicing on getting my handwriting better on
No, you're fine. It's just-
On these. I've been working for a year. I'm starting to get used to it. I've been doing it for a year. Okay, so go back to my problem so I can make sure, because that one, I did look at those commas and they look pretty bad too. All right, so I need 5. They put SF, they did SFT, yeah. They want hectare acres and square vector chain. So I'm gonna need the hectare acre one, that's gonna be in the front. So there's a couple places for this one that I'm gonna refer to in the book. So square area, 1 hectare equals 2.471 acres. So I'm gonna look at that one. I'm gonna look at 1 acre is 43,560, and I'm gonna know that 1 acre is that 10 chain squares. I'm gonna be doing those. So back then, in this, when they were using chain squares, I'd say early 1900s, if they did, they had those chains, they made it even. It's kind of like to me, the international unit is so much better conversions. You go from centimeters to meters, they're all factors of 10, okay? Now, we're talking about to go from inches to feet, we gotta divide, how many inches by 12. Or if we're converting to something else, they're 5,280 feet in a mile. We've got all these oddball numbers, and I feel like that, but that's the way of life that we have it. But we do a lot of stuff, there's 1,000 grams in a kilogram. Everything's factors of 10, so they prefer the international units, but us in the United States are got these oddball measurements. So here's these oddball measurements we're going to be working with right here. So I just need to write 1 hectare is 2.47 acres. Is it 2.47? Is that what I just said?
Yeah.
471 or 2.47?
Yeah, it is.
Okay, so I got it right. Okay, so I want to convert it to acres. So I'm going to look at, so it's in square feet and I want it in acres. So I'm going to be looking at that one. So I'm going to go ahead and bring it down. Okay, so I'm solving for acres. So the acre will go on top and the 43,560 will go on the bottom. So square feet cancel. So I'm going to divide $5,000 or 5,377,700 divided by 43,560. I got 123.455 acres. And it would round out 00. I'm just roughly 123.45 acres.
Did you just decide to skip that those are survey feet, or?
Oh, not putting the S here?
No, the original problem was survey feet, which should be a different conversion to acres, should it not?
No, it's the same thing.
It's considered close enough.
Mm-hmm. Yes, considered. The only time we'll have to differentiate between the two is only when we're converting from meters.
Okay, so the general rule outside of the metric is the same? Okay.
Good question. So now let's see what the book has to make sure. They got 123.46. Now, I need it in hectare acres. And I've got, since I've already gotten acres, I'm gonna bring the acres we just solved down. And they want this one in hectaacres, so out of that 1 hectare, it's just gonna bring it straight down for me. So I still have that in my calculator, so I'm just gonna divide it by 2.47.
49.9.
And they did 961, but since I didn't round, mine would have rounded up to, be sure I didn't put the wrong, did I miss the 1 on that one?
Yes.
I did.
2.471.
What is that error? I did notice it's
Right there, right.
1% base square kilometer, but is it defined off kilometers?
471 acre. So if I divide that by the 2.47, I've got that little 1. I got 49 point. We'll take a break after this in just a second too. I'm going back up to my first one. And I got 1.5, it would probably round up because it's 1.555.
I got 1.588.
Yeah, that's what I got. So this, this test is a paper test, but I let them take it home to do it. But here's what I told them, you have to show all your work to get credit for it. Because I do know that, we can look up conversions online, just show me your work. That's all I would ask for, is show me your work. All right, square Gunther chain. So that's the next one. So I do know that 1 acre equals 10 chains squared. And I've got acres right here.
Divide that with
No, we're going to multiply it, and I'll tell you why. So this is what they want our answer in, is square Gunther chain. So that means the 10 needs to go on top. And the 1 acre goes on bottom, so that these cancel out. So you're just going to multiply it by 10. So it should be, the book has 1,234 point, and they did 6 because they rounded up. So I'm going to go back to that 123.455 times 10. By 5. I don't know if they call it let's see how they write theirs. so I don't have to spell it all the way out. They just put chain squared, CH squared. Because a chain is actually 66 feet. But when they measured it, it was kind of like a steel pole rod. And it was 66 feet, and they would lay it down 10 times. 10 that way and 10 that way. And that's where how they measured that out. All right, ready for a break? Not too bad, is it? The more we work, the more you'll get familiar with where to. So whatever we're solving for, we'll put that number on the top. And so to me, that was the easiest way for me to understand it. But there's different ways to do it, but I always know whatever I'm solving for, out of whatever the conversion is. All right, the conversion here, whatever they ask me for, I put that number on top, and then whatever, the other number I put in the bottom, because what it is, this is gonna cancel each other. Acres cancels, and you're left with hectares. But that's that's chemistry. That's a big thing, conversions with them, and same with, we don't do it to the extent they do it in chemistry or physics. We do a little bit of this conversion in soils and foundations and engineering materials, but not to this extent. This is what we're doing in chapter 2 is pretty extensive, because we want to give you every single thing we can think of that you would see. All right, get your break. I'll get the next one on the board while you're getting your break.
Christensen, you're putting us, conversions on there every time, like, want to, put it in over.
Every time. You will decide which one goes over it of what we're solving for. And I'll write out what the conversion is for you, so you'll know where to look at in the book. Is that what you're asking, like what the conversion is?
Like, the way I did it, I was like, whenever I seen temperatures, I'm trying to,
And so what you'll say is, okay, out of those, out of any two that you're looking for. So 1 mile is that, if they give it to us in miles and they want it in feet, then I would know the feet has to go on top and the mile would need to go on the bottom. So I'll look at the two numbers and put them in that formula, like one over the other, either one divided by the other or that number divided by 1. Like I said, we'll do it with every single thing. We'll just look at what the conversion is and then what we need to solve for, and that tells us which number needs to go on top out of the two, like those two, these two. What's that? The surface?
Oh, okay.
Oh, that, okay. So, I had gotten on when I was doing some of the formulas at home, last summer, I was trying to, I don't have this nice big smart board or sharp office at home. So I had to buy like a Wacom tablet, a tablet where I can write on the tablet and you could see where I wrote, but I did it in Word. And then I could save it as a PDF for them once I got through, but they would watch. I put the formulas on one side, but I screamed, so I put formulas on one side, I put the Word document on the right side, and I would write in the Word document and talk while I'm writing and work them out. And the engineering, Mr. V that some of y'all have for CAD, he did our statics class, and he would aim his camera down to where you would see as he's writing out, and he would explain his. I could never get mine to angle, so I had to put something that I could put them side by side at home, but, they just bought just got a Surface Pro from school, because they said that writes real good and straight into like Blackboard has a whiteboard in it. And so I got just in case we get sent home or something happens, I'll get it up and running, but, like, so they have a whiteboard that I could do a whiteboard if I was at home, and the Surface will let me write on it just like I'm doing this. I like to write big anyhow. Here we go. So I've got 23.4587 hectaacres, and they want it in surveys SFT square feet. They said. They want it in square survey city. Okay. Acres and square footage. Well, I'm gonna go ahead and drop down, because I think if they're wanting in, I'm gonna convert it to, I got it in hectaacres, so I'm gonna convert it to acres first. So it's 23.457 hectaacres, and they want answer in, oh, I'm dropping down to the middle one. Sorry, I knew it's the acre one I'm gonna solve first, because then I can convert that to square feet. So out of this, it wants our answer in acres. That means the acres out of the 1 hectare equals 2.471. The 2.471 has to be on top, which is we're going to multiply it. So if they basically your hectaacres will cancel, and so you multiply. So whatever you're solving for, you always put that number on the top. So in this case, we just multiply these two. $57.96. Now they had something different, so let me look. They got 57.9676, and I got 57 point.
9664.
Yeah, let me make sure I wrote everything down right from the book. So my convert 23.4587, so that's correct. So I don't see anything that I put in wrong. So I had 57.966 acres. And if I was specifically looking at significant figures, I'll just kind of throw that out there. This number has 1, 2, 3, 4, 5, 6 significant figures. This one, whoops, has 4. So my answer would be 57.97 if I wanted to round it to significant figures, whatever the least is of the two. Y'all do that in, which you wouldn't have just somebody that had it before. Did y'all have any of that in EGR 115 at all? Any like conversions?
Yeah.
A little bit. Okay. But most people, when you don't get that into that till the spring. So I solved for acres. So now if I have acres, I'm gonna go ahead and bring it up top. And I'm gonna leave it at 966. And I need to use this to convert it to square feet. So I'm solving for square feet. So square feet's gonna go on top. I'm gonna leave it, mine's already in my calculator, so I'm just gonna multiply that by 43,560. $2 million, that's what they got. 2 million. Now I left mine all the way in the calculator. 525 018.462 square feet. So you will notice the book will do like a little foot with the square behind it, but the same thing is true with SF would be square feet too. And I'm so used to putting SF, so if you'll see me, feet squared and SF are the exact same thing. I just put SF when I'm doing, putting in CAD. All right, so now I gotta convert that to Gunther chain. So again, that's this last one. And since I have acres, I'm just gonna bring it down that we just saw for an acres. We're wanting it in Gunther chain, so 10. Go back to your 23.4587 and multiply by 10.
Just 10?
Just 10. Let me make sure I got it right.
Meters before we multiply it by 10?
I did something wrong.
10 square cans per acre, not per
So
hectare.
Yeah, I did something wrong. I was like, I did something wrong.
966 tons.
5 seconds.
No, I put the wrong thing in there. Huh. Okay, I want it in chain squared. And I have acres, but my acres was this number. Is that what you got?
Yeah.
No, I think I put my decimal place in the wrong place.
Yeah.
Yeah, you just.
57.966. There you go. That's right. All right. Next one is computing the area in acres of a triangle lot as shown on a plat. So we're gonna have to do the area first in square feet, and then we'll convert it to acres. So I'll draw it up for you. Nope, I skipped one, 2.9 first. 2.9, what are the lengths in feet and decimals, in length in feet and decimals for the following? So it's actually 12 feet and 6¼ inches. That's A and B. Ten feet, 8½ inches. I already know that's going to be 12.5, should be 12.52. 12.52. That's what I'm going to say it is. I'm going to say that's that one. So let me see. I'm going to put them off to the side. All right, so I'll bring the 12 down. I've got a quarter, 1/4. I got a 1/4 inch. You're going to take 1 divided by 4 and add that to my 6.25. And then there's 12 inches in a foot. So I'm going to divide this number by 12. So you told me 12.52. So you'll divide your 1 divided by 4 to put it in decimals, because that's in a quarter inch, and then add that back to your 6, and then divide. There's 12 inches per foot. I see these at least once a week week or more because of getting the conversions in. And y'all done the CAD, anybody done the CAD before? It's the first time you ever done CAD. Y'all have CAD. Well, a lot of times the CAD will do it in inches, or you get the label in inches or decimals of a foot. But typically, if builder's trying to get a site plan and they want to put the house on a lot and take it to the inspections department to be able to get a permit to build, I convert all of those inches and decimals of an inch to decimals of a foot, because they're gonna want to see that on there. So I do all the conversions before I even put it in CAD. And I usually do them in my head. Every once in a while, I'll do them wrong, but then they don't close in CAD. When I'm putting them in CAD, I was like, the bust here, what did I do wrong? All right, next one, what was that? What was B, because I erased it. It was 10.
10 foot, 8.5 inches.
Okay. Bring 10 down. I'm gonna 1 divided by 2, so that would be 8.5. And then we're gonna divide that by 12. So I'm thinking it should be about 10.71.
I got 10.7.
Okay. 1 divided by 2. Add it back, that's 8.5, and then we divide that by 12. 708. So I got 10.70833, and it repeats. So I'd say 7.1. So the instruments that we use outside, it reads to 2 decimal places, so decimals of a foot, but it goes out to the hundreds. It's either a 0 or 5. So it may read, if I'm reading 100 feet, let's say it's 101.51. It reads this last number, but it either is a 0 or a 5. So it's not out to the thousandths. It reads 0 or 5. And that's so minuscule, you can't hardly see it. So it reads, when we start going outside, you'll see it'll read that to 3 decimal places. So that last one's either 0 or 5, because it's rounding up. So I just recently, well today, I went to my office. I'm talking about, I told y'all we had bought new equipment for Federal Tech, and they invested almost $27,000 in a robot. Well, the company we bought it from calls, and they're part of the Education Foundation. He's on the board, and he wanted to know what we were using, what we could, trying to at least get more equipment and more hands at a local community college so that you guys are trained on the latest and greatest. And so that one we got was the latest and greatest, but we won't be using it in Survey 1, but you're going to use something similar. You're going to use a total station. So I'm not going to make you do something that you can't do everything electronically. But yeah, he called today and wanted to talk about what they could do, trying to get new surveyors in and new blood. So the guy that called, he came and trained us when I was at PwC on our equipment, because nobody was using the GPS, they were using more like MacRay. And he came, and back then, they had all of the military, you would have to send your data off. And it didn't do real time because they had it scrambled. And he spent a whole week with us. And every day when I walked out from work, I felt like my head was on fire because it was so much stuff. I just feel like boom, it's like I was gonna explode every day. So by the end of the week, we were about to kill him and he was about to kill us. So there was like 4 of us in there and him. He was like, I guess it was a lot. And it's so much simpler now. But yeah, I felt like I'm gonna remind him of that when I call him. I'm like, yeah, we're about to kill you and you're about to kill us. So I feel like here as a community college, we have been keeping up with the times. I'm constantly having to update material because that's one of the challenges in surveying is that technology changes so much. A lot of times it was easier to rent the equipment than purchase it. Because we have equipment prior to that, that within a couple of years, it was just outdated. I mean, those ones, the one I had out, the handheld one I had out, they're 6 years old. They're already almost outdated. So we got 4 new ones. So just that quick, things change. And, you know, we get more precise, it comes down to cheaper. Survey equipment used to cost $100,000 just for what we just got now that's $26,000, 20 years ago. You wait a little while, it comes out. All right, now we're gonna do 2 triangles, really quick. So 211, it's a triangle. And it doesn't matter, okay, so 330. And make sure you got the book that I'm writing it right. And it said this is 800, and it's not to scale, so 804.026. So 3 common things we do in surveying. An area of a triangle, area of a square, or area of trapezoid, or 4. And then we do area like a, you know, not what's the one, not the square, but if it's long, it's like your length time width. What y'all call the shape of that? Rectangle? Okay. Rectangle. We'll go with rectangle. So we do triangle, square, rectangle, and we do trapezoids. Those are the main ones that we use. So area of a triangle is 1/2 base times height. So my base I'm sure if I look in the book, these are both feet, so they're on there. I'm sure they got the formula in here. We use it so often, it's probably in the back or something. I know, just in case you didn't know anything, I was looking to see if it was in here, but I don't see it right now. But I know we do it in other things. We'll do it when we start doing areas, which are in chapter 12. So we'll get to areas in there, but. So 1/2 base time height. And then it wants it in acres. 1 acre is 43,560 square feet. 335. Oh my God. Tell me what you got for. Did you get what I'm getting?
Yeah.
Just for the square feet.
Yeah.
So this is funny. So when I first started teaching, the very first class I taught, I was a survey 1 class at night. That was in 2005. So a lot of times we would kind of work these together. It was a really small class. So the first test I gave them, because we'd always say, well, what'd you get? You know, they'd say, well, what'd you get? This is what I got. So normally they would holler out what they got. First test they got, the guy started giggling. He said, I was getting ready to holler out, what'd y'all get for number one? He's like, yeah, it was a test, but we were so used to just, what'd you get? You know, talking amongst ourselves. He said, I was getting ready to holler, well, what answer did you get? And he said, I realize it's a test, but that was kind of, I won't forget that either. So if I want to convert that, that's in square feet, to acres. 1 acre is that, so I'm going to go ahead and write square feet up here. Out of those two numbers, what's going to go on top? Is it going to be the acre or the square foot? Acre is going to go on top because we want the square foot to cancel. So these square foot are cancel. So we're wanting to answer in acres, so the 1 acre will be your top. So the big number, we're going to divide that by 43,560. So should get roughly 3.095 acres. And they did 3.0945. It would be 45. I just rounded it up. Okay. Next one. Somebody give me the two links that they have for B.
93.064 meters.
Oh, meters. Okay.
And 30.346.
346.
Correct.
And they want it what, in acres?
Yes.
Okay. So do we want to convert it to feet first? Or do we want to just go ahead and do the area in meters squared?
That'd be straightforward.
Because I know 1 square foot equals 0.00929 meters squared. So I'm just going to probably, and then I convert it to acres. I'm going to leave it like this. I'm going to do area of a triangle. And I'll show you where I'm getting the other conversion. That's meters, meters. That what, you get that? Yes, no. That look right?
I have not. That's that wrong?
30 point. Did anybody get what I had? No, so I must have just put something in wrong.
Yeah, I went 1412.06.
Yeah, that's what I got too. I don't know what I put in wrong. I did put something in wrong. I got the formula written off, typed something in wrong.
We bet you dropped to 0, 30, type 33.46.
Is that what you get now? That look better? Okay,
Yeah, I got it.
thank you. All right, so I'm gonna convert it, and I'm gonna look at the very front of the book again, and under area. Let's see. Under area, I see 1 feet squared equals to 0.092 290. I don't think I see one that automatically converts it from meters squared to acres. Let's see,
It's the
kilometer.
bottom acre one.
This, we're at
46.9.
It was in 1 acre is equal to.
The third, acre plan.
is it on this page?
Yes.
Yes, it's 4,046, it's two under the, it's under the.
Where am I?
Oh, it's above 1 foot square,
1 foot squared.
right above it.
Yes, there you go. Thank you. Right here. Okay, 1 acre. You can see I don't do those near as often as I should. All right, so 1 acre equals 4046.9. So I'm gonna write 1 acre is 40. I was trying to 469. Do I have that written right? I'm solving for acres. So 1 acre goes on top. So I'm going to take that number and divide it by 46.9. What did I do wrong now? Because that's not supposed to be the answer, I don't think.
Same thing I got.
Okay.
Yeah.
They forgot to do half. That's what it is, the textbook didn't. When they solved their area, I think they did length time width, because they got 0.6978. So y'all got what I got, is that what you're saying?
Yeah, I got that.
Okay. So I just say that my textbook solutions aren't right. All right, the last one of the day. We got, so I think, no.
You paid so much for these textbooks, it better be right.
Yeah, well, it's the solutions manual. The book's right, the solutions aren't right. My solutions aren't right sometimes. Textbook, I really hadn't found a lot of discrepancy. It's the solutions manual. What happens is they keep changing the textbook,
Yeah.
the problems, and then they forget to update their solutions manual correctly.
That would take too much thought.
Yeah, I know. So I found that out to be true like last one. So this is 216. Convert an angle of a triangle, and show your computational check. So the first one, and they want us the angles 2 radians. So I'm going to put this up here real quick. That's one. So 39, 41, 54, and there's your seconds, degrees, minutes, and seconds. The next one is 91 degrees, 30 minutes, 16 seconds. I'm going to do A first. This is 216. So they want our answer in radians. To convert degrees, minutes, and seconds to radians, it's multiplying it by pi divided by 180. Now let me see where they have, I don't know that they have, pi is 3.14. 1 radian is roughly, I think it's in the text when we were talking about it. I'm gonna do it the long way, and then I'll show you how to do it in your calculator. So if I want to convert degrees to radians, but you cannot put this in the calculator like that. That's in degrees, minutes, and seconds. So that needs to be converted over to decimal of degrees. So 39 is going to drop straight down. If there's 60 seconds in a minute, you would take your 54 and divide it by 60. That gives me 0.9. And then I'm going to bring the 41 down. And then there are 60 minutes in a degree. So I take 41.9 divided by 60. And so that's where I'm at. So it's 39, and that's repeating. If I want to then convert pi divided by 180. So I'm going to do times pi divided by 180. 39. Now I'm going to show you how to do it in your calculator too. So what's pi? What do you typically use for your number for pi? See pi in your calculator. 3.14. There's pi. Oh, let me do it like this. There's pi. If you put a mirror up, it's 3.14. Pi, P-I-E. I usually kept putting it in the calculator, but the word pi, you put the mirror up there, you put it in there, it's going to look like 3.14. That was just a little. So we can do this in the calculator, this converting. If I want to convert that over, if you got a TI 83 or 84, probably 85, it's 39. The degree symbol is under second apse, because that's angle. And the first one is degrees, so I'd say enter. And then 41, the seconds is under that second apps, and it's the second one down, which is minutes. But here's the kicker, the 54 seconds, it's under alpha and the plus button. Seconds is in green. And if I hit enter, then there's what we just converted all out by hand. If you want me to look at the one you have and see if we can figure out whatever you bring in. Yours probably does it easier than mine does. Yeah, yours does it easier.
What did you say, you can find the second button?
Alpha. And it's the plus button right there. See the little seconds there?
Okay.
And then I just hit enter. And then now I can say multiply it, and pi on mine looks like that second little caret. And then divide it by 1. And I got 0.6928, because I kept mine all the way out this time. This one I had rounded. I'll know what you did if you're writing this stuff out by hand. I can follow what you did. I'm not gonna be sitting there saying, well, you got it one way. I'll know what you did. Some of these calculators work better than others. Is that? I'll look, I had somebody have that. That's the newer one. I'll have to ask them.
I'll
That
have to
one.
look it up.
Second angle, which is the absolute. So put in 39, and then do second. Do second angle. And it's got instead of 1, yeah, 0. Yeah. And then 41, and do second. Seconds. So let's see if like way over here, here's the seconds. So that's alpha and the plus one. Now these I do all the time, so I know exactly where it is on this. But if you have one, you want me to try to look it up for you, or you can do it simply right here. So we did the first one. So so this is a triangle. So it gave me the other two. So I'm gonna go ahead, 91 degrees, 16 seconds. I'm gonna go ahead and bring my 91 down. I'm gonna do 16 divided by 60. I'm gonna do it the hard way right now.
Whenever I put my answer in, I tried to my pi over 180.
Mm-hmm.
Something slightly different.
Yeah, it might be, because it depends on how we keep it all the way. If you keep it all the way out, I'll be able to follow what you do on a test. Because when I kept it all the way in the computer and didn't, or in my calculator, I got something slightly different than this number. This one was 0.69 something other. So add that to 30.
Do you do that to all three of the,
Mm-hmm. So so I changed it from 91 degrees, 30 minutes, 16 seconds to decimal degrees first by taking 16 divided by 60. And I got 0.26, brought that down, added it to the 30, divided by 60, and I got 0.5, that's a 5. Something like that. And then I'd multiply that by pi over 180. I got roughly, for that one, 1.59705 for this second angle. the first one, I had 0.69 something. I took it out. What'd y'all get for the first one? 0.69 something. The very first one I put in because I erased it.
0.69287.
Okay, thanks. And then the last one. So what's going to happen, we can kind of check our work. So we can actually make sure that we're right and didn't make a mistake on something. I'll show you how to check it. So the last one, 48 degrees, 47 minutes, 50 seconds. Bring my 48 down. About okay. Times pi. Nope. What'd you get?
I got 0.85.
Okay. So there's an answer. There's an answer. And there's an answer. Add them up and tell me what you get. And just roughly. And then see if that number looks familiar. You add all your three where you converted to radians. And we're going to go after this. What'd you get if you added all three together?
3.14.
What is 3.14?
Pi.
Pi, yeah. So there's a computational check. All right, you got notes on it? As you go out today, come through and let me see your notes that you wrote on it. If you didn't write good notes and you want to show it to me, you come in Monday, but this is going to be an activity grade for you. And we're not going to finish the second part of that. We'll be outside Tuesday and Thursday of next week. I'll remind you again, I'll put like something in Blackboard, okay? Tuesday we'll be outside, so it's supposed to be fairly hot. So I'll try to make sure we bring some waters. And I know that we can set the instrument up in the shade and we put the person in the rod only in the sun. We'll try to find as much shade as we can to be outside on those days. All right, so I'm good to go. Just stop by and let me see your papers. Sorry. Quiet.
I'm sorry, the first one, like, 2.4, 7, 8,
I'm gonna do this. I'm gonna have it. Okay, got you. Okay. Gotcha. And, okay, and mine full run.
Somebody found that you on the library.
Oh, okay, thank you, because I didn't even hear you. That's okay. As long as you can read your own handwriting, I don't care. So somebody messaged me, let's see, thank you for letting me know, because I sure didn't see that. Yes. Or you can hook it in you can put it in Blackboard, so if you are doing this virtually, you'll need to submit, you can attach it right here under class assignment. I think I got the due date today. Let me look. No, I didn't have a due date, so I'm gonna put, because we did this in class. I'll put the end of the night. So yes, thank you. So if you're doing it virtually, or you're watching this tonight, make sure you write down these problems I went over and scan it in and email it, or just take a picture and email it to me. You don't have to, it doesn't have to be anything fancy.
Through this, I did not get the 1.5, I got 0.0.
This one?
Yeah.
You think I might have put them in that one?
This was number 1.6. I'm just wondering if I did something wrong. Probably sure I did.
So you're getting this, not the 0.6.
It's just breakdown.
Oh, that's what it is.
Oh, okay.
That would have been mine, or either I might have wrote it down on that, right? But it's not even mine.
Yeah,
I bet that's what it is.
Okay.
That's a quick, oh, okay, I'll see
Hopefully, I come out there like, okay.
Yeah, that's fine. You're Daniel, right? Yeah, but you probably can do it. What kind of color were you using? Okay, because also you had used an answer before, I did. I was always a Hewlett Packard person.
I also just worked pretty much straight through at the beginning.
I was a Hewlett Packard person. All right, we're going to look at switching something for you.
I don't know, you're just.
That's okay, Devon, what you got? Oh, I understand. So you know, you're not, yeah, do you want to, you just want, you just want to practice, yeah. I'll go run around my office real quick, so once I finish with him, then we'll go out. So anytime I do something like this in class, then I'll put a due date. If you're doing it virtually, just take a picture of your works. Usually you've done it. Okay, so I did talk to him today already.
Okay.
And, so he knows you're gonna be gone, but he said once y'all start working in drawings, he'll have something to say, do one that's on page so and so. He's not been recording, but he's gonna have to record it because we have somebody that's out.
Like how you, right now, you're broadcasting, right?
Yeah, but, so I'll explain. You know how in GIS, y'all were working on those certificates, through there, and I didn't do it with you, I was like floating around the room and had you work on, that'll be kind of what you're doing. Unless you come with a problem, then you probably could share his screen, he can probably share his screen with you. If you're working on this during the class time, you probably share his screen. If not, you're just gonna have to look at what his list of drawings are and when they're due. Because the book should give you the step-by-step instructions, kind of like they did when we do, you know how y'all do have problems, you might have to say, hey, I'm not getting quite that. And then you can save any AutoCAD drawing as a PDF. So you don't want to probably send, he probably's not gonna ask for the whole drawing. Like a DWG, he may not. Just whatever, you can save it as PDF or you can send him the drawing. He's in class, he can open it up and he has got it work.
Well, attendance to it on that, let's say this afternoon, I just look at every on that,
Took it in your syllabus quiz? I'll ask him if he can report tonight, because if he's going over, he may be, while y'all are getting your book, show you some of the different features Audit had, like run through the ribbons and stuff. So I'll ask him, I'll ask him to do that. So, but he said once you get to the drawings, it wouldn't be that big of a deal, because he's gonna say, do this drawing on the page, and it kind of gives you step-by-step instructions how to do the drawing. Kind of like this online part of the book, you know, that when I was having you do certificates, I didn't record anything on those days. I just said, do your certificates, and then I'll kind of float around in that one where y'all had to trace that road. So it'd be kind of like that. Yeah, Mr. V said he hasn't been recording. Get with maybe 15 minutes. You're gonna just leave your stuff in here? Okay, about 15 minutes and I'll be ready to go. We'll go run out. We'll find somewhere in the shade. So if you walk out, if you happen, Giovanni, walk out, just kind of pull it a little bit. Just don't let it click. If not, come get me in the office.
Okay.
Like, and this and the day in a class with no, I mean, I made me earphone, I'm going to pull up on the video again, I'm going to go so the next time. Like, yeah, yeah, I would be if it yeah, we ain't one thing, and I'm going to get everything. But, yeah. Yo, the man even said, I'm being virgin. The man has a man being virgin. The man just caught. The man just caught. And the fact of that, the man has a not running a chase as being said, me not really realize you're chase. But you don't know the crow. Hear taste, because I taste me here first. Isn't it? But when you listen to people that chase the man say, and if you follow the lyrics and chase me, isn't it? Yeah, but the man friend just run away like it. And the second video with the casket business, he tired the man. up, man? You good? Your birthday, right?
Yeah.
Happy birthday, man. What you up to? Yeah. You got any plans? I'm free Saturday, Sunday. I think I'm free on Saturday and Sunday. Yeah.
Yeah, so you can, I think, we're going to Florida.
How long?
Then, yeah, but it needs a while for, depending on when we might go to the other Saturday.
You come back before the 11th of September?
For what?
The 11th of September?
Yeah.
Yeah, so we got plenty of time.
It's official, I got a date.
Yeah, the 11th.
We're overseas, we're overseas,
The Cayman Islands.
you go over to,
Yeah. Probably come after, but not leave with me. I gotta go get settled first.
probably,
Until January?
Did you put your name, first
My
initial,
bags,
last
bags,
four of
bags.
your
I'll hit you
data
up.
tail at ad.faytecc.edu? Put AD in the front first. A lot of, and do you have a Chromebook? That would be my other question,
I use my laptop.
is what,
It's not a Chromebook.
okay, so it should, I bet I know what it is. I bet it's,
Yeah, that's the link I use.
okay, oh, let me go back. So you've got to put at ad.faytecc.edu.
Oh, it's slightly different.
Yeah, so it's your last name, first initial, last four of your student, at, and then put ad.faytecc.edu. What that means is Active Directory. So whatever your password that you use for Blackboard, you'll put that in there. So I bet you forgot to put that in there, AD.
It's just AD.
You have to put all that in there just like that. So
Okay.
yours would be, where's your paper, piece of paper at? And you click in. Usually that's where your. At ad.faytecc.edu. So you have to put it in just like that.
Okay. Oh, yeah, it probably was slightly wrong then.
Yeah, because you probably did, at FAYT, you
Yeah.
didn't put in that word AD, Active Directory.
All right, thank you so
So
much.
that should work. So like if I was doing mine,
If it doesn't work either, they said
It
they
will.
have to call the IT thing. But
It
I'm for
will.
sure.
I guarantee it will.
All right. Well, thank you so much. I
You're
really
welcome.
appreciate it.
Just keep me in the loop of things and we can add that other
Mhm.
stuff on if we need to, and go ahead and run it through financial aid if we need to, because it would start to October.
Okay, cool.
And then we just plan on you going into 171 in the spring.
All right.
So
That
you'll
sounds
have
good to
enough
me.
classes for that.
All right. Thank you so much.
You're welcome. All right, Giovanni, you ready to go out? So you're just gonna practice setting up.
Yep.
So can we find a shady spot? Shady spot somewhere?
Yeah, that's-
So we want to see if you can do it in 3 minutes or less. So you want me, I'll show you, and then I'll let you try it again and
Am I
again.
gonna use a pen?
Huh?
Am I gonna use a pen or it's gonna be one of those?
I'm gonna do it, I'll grab a nail.
Alright.
I'll grab a nail. Which one had I let you use, the one that has the optical plumb or the laser?
Jimmy.
The optical, the big heavy one? The big heavy one is the one I had you use that we had to put the battery in, right? Because a lot of times, the other one is easier.
Remember, I use a letter as soon as possible.
I will, I'll make sure I get it this weekend for you.
So then you can add it to my file.
I'll show you how to set it up there, so you're different. It is. Everything else is the same, but I'll show you. It's got a laser. Instead of looking through the optical plumb, a laser turns on. Get your tripod legs. Yeah. I don't know where the coolest area is gonna be at. I'm sure we can find something right out here. Under the edge right there. That won't be too bad, right out the back door. You go ahead and lower them? Yeah, go ahead and lower them. So you don't have to.
Long semester.
You can do it in spring, what you talking about long? You just know you got a lot of work to do and some other stuff going on too.
I mean, all the way to.
either by design it, or it was my subdivision, or I had surveying in it, or both. Yeah. Yeah, I locked that one up, so I used to do put that in with the data collectors.
Fun course, that was math. I thought I was going to get away from math, I guess not.
Oh, no.
Math.
But it's just basic math.
Yeah, I got through